Welcome to Milky Narratives. Find a comfortable place to rest, let your mind unwind, and allow the worries of the day to fade away. Tonight, we'll travel through the vastness of the cosmos and discover the stories hidden among the stars. Sleep well and enjoy the journey. 1. The planet where metal falls from the sky. Some worlds don't have rain made of water. Instead, their clouds release glowing rivers of molten metal, pouring endlessly through an atmosphere hotter than almost anything we can imagine. It sounds impossible, not merely unlikely, but completely impossible. If someone had described such a place only a century ago, it would probably have been dismissed as fantasy, a landscape invented for a science fiction novel, a world built only for stories about distant galaxies and impossible civilizations. A planet where iron falls from the sky? Surely nature could never create something so strange. And yet, nature did. Hundreds of light years from Earth, beyond the reach of every spacecraft humanity has ever launched, there exists a giant world where the weather follows rules unlike anything our ancestors could have imagined. There, the clouds are not made from tiny droplets of water. The rain is not refreshing. The winds are not gentle. Instead, temperatures become so extreme that even solid metal loses its shape, evaporating into invisible vapor before eventually falling back toward the planet as glowing droplets of liquid iron. This is not a prediction. It is one of the extraordinary realities astronomers have uncovered as they continue exploring the thousands of worlds beyond our solar system. And perhaps that is the most astonishing part of the story, not that such a planet exists, but that we somehow discovered it while standing on a tiny blue world orbiting an ordinary yellow star. For thousands of years, humanity believed the universe was probably much like our own neighborhood. After all, our solar system appears remarkably organized. Small rocky planets circle close to the sun. Larger gas giants occupy the colder outer regions. Beyond them lie icy bodies drifting in darkness. Everything seems balanced, predictable, almost comforting. Even after telescopes revealed countless stars filling the night sky, many scientists quietly assumed that other planetary systems would probably resemble ours, perhaps a few differences here and there. A slightly larger planet, a slightly smaller moon, maybe another asteroid belt, but nothing truly unimaginable. Then, during the last few decades, something remarkable happened. Our instruments became sensitive enough to detect planets orbiting distant stars. At first, each discovery felt almost miraculous. One new world, then another. Soon dozens appeared, then hundreds. Today, astronomers have confirmed thousands of exoplanets, and every year that number continues to grow. Each discovery has expanded our understanding of what nature is capable of creating. But instead of finding familiar copies of our own solar system, we discovered something far stranger. World after world refused to follow our expectations. Some planets circle 2 suns instead of 1. Others complete an entire year before a single Earth day has passed. Some wander through the galaxy completely alone, having lost their parent stars billions of years ago. Others may possess ring systems so enormous they could dwarf the orbit of Venus itself. Some planets are colder than almost anything imaginable. Others are hotter than certain stars. The more we searched, the less ordinary the universe became. It almost seems as though every time astronomers think they understand the limits of planetary science, the cosmos quietly smiles and reveals another impossible world. Perhaps that shouldn't surprise us. After all, our own solar system represents only one tiny example among hundreds of billions of stellar systems scattered throughout the Milky Way. Imagine walking into the world's largest library after reading only a single book. Would you expect every other story to unfold exactly the same way? Probably not. The universe appears to work much the same way. Every planetary system tells a different story. Some are peaceful, some are violent, Some are breathtakingly beautiful. Others seem almost hostile to the very idea of existence itself. And somewhere among those countless stories lies a world where iron falls from the sky. To understand how such a place could exist, we first need to forget almost everything that feels normal about weather. Here on Earth, weather begins with water. The oceans absorb warmth from the sun. Water slowly evaporates into the atmosphere. As it rises, it cools. Tiny droplets gather into clouds. Eventually, those droplets become heavy enough to fall back toward the ground as rain. The entire process repeats over and over again. It is such an ordinary cycle that most of us rarely stop to think about how extraordinary it actually is. Everything depends on temperature. If Earth were just a little colder, much of that water would remain frozen. A little warmer, and enormous portions of our oceans might exist primarily as vapor. Change the temperature, and the entire character of a planet changes. Now imagine increasing that temperature not by a few degrees, not by 100 degrees, but by thousands. Imagine moving an enormous planet incredibly close to its parent star. Closer than Mercury lies to our own sun. So close that one complete orbit lasts less than 2 Earth days. The sunlight never really fades. The heat never truly escapes. The atmosphere itself becomes an enormous furnace. At temperatures exceeding 2,000 degrees Celsius, substances we normally consider permanent begin behaving in unfamiliar ways. Rock softens, minerals melt. Even iron, the metal humans have relied upon for thousands of years, can no longer remain solid. Instead, it becomes part of the weather. Iron transforms into vapor. Invisible currents carry it through the atmosphere. Powerful winds race across the planet at incredible speeds, transporting that vapor from one hemisphere to another. Eventually, the temperature drops just enough. Not enough for comfort, not enough for life, only enough for iron to condense once again. Tiny droplets begin forming inside alien clouds. Except these droplets are not water. They glow. They shimmer. They fall like liquid fire into the darkness below. It is difficult to picture because nothing remotely similar exists anywhere on Earth. The hottest deserts on our planet barely scratch the surface compared to these unimaginable conditions. Even the lava flowing from Earth's volcanoes would seem almost ordinary beside an atmosphere where entire weather systems revolve around vaporized metal. And yet, this is only one planet, only one among thousands we've already found. Which naturally raises an even bigger question. If this much diversity exists within the relatively small number of worlds we've already discovered, what might still be hiding among the hundreds of billions of stars we have barely begun to explore? Perhaps there are planets where diamonds fall like snow? Perhaps oceans made from unfamiliar chemicals stretch beneath skies unlike anything human eyes have ever seen. Perhaps entire classes of planets exist that we haven't even imagined because our experience is limited to a single tiny corner of the galaxy. History teaches us something fascinating. Every generation believes it has nearly completed the map. Then nature quietly unfolds another continent. Astronomy has followed that pattern again and again. We once believed Earth stood at the center of everything. We were wrong. We believed our solar system contained all the planets that existed. We were wrong again. Then we imagined other planetary systems would resemble our own. The universe surprised us once more. Every new telescope has expanded not only our knowledge, but also our humility. Because with every discovery comes another reminder that reality is almost always more creative than imagination. And perhaps that is why exploring the cosmos remains so endlessly fascinating. The farther we look, the stranger everything becomes. Tonight, our journey begins with a world where molten iron falls from glowing clouds. But by the time our exploration is over, you may discover that this astonishing planet is only the first chapter in a much larger story. a story revealing that the universe is filled with places so extraordinary that even our wildest dreams have yet to catch up with reality. 2. The year that lasts. Only a few hours. Imagine celebrating New Year's Day several times before you've even finished sleeping. On Earth, that sounds impossible. A year is something we instinctively understand. It marks the changing of the seasons, the slow journey around the sun, the passing of birthdays, harvests, generations, and history itself. Entire civilizations have built their calendars around this dependable rhythm. One trip around our star, 365 days. It feels almost universal. But the universe has never promised that Earth's experience should be considered normal. Somewhere among the thousands of exoplanets already discovered, there are worlds where an entire year lasts less than a single Earth day. In fact, on some planets, you could celebrate New Year's Day dozens of times before a child on Earth even finished their first week of school. It sounds absurd, yet it is simply another consequence of nature following the same laws of physics under very different conditions. The length of a year has only one definition. It is the time required for a planet to complete one orbit around its star. Nothing more, nothing less. Here on Earth, that journey covers nearly 1 billion kilometers and takes about 365 days to complete. Mercury, being much closer to the Sun, completes its orbit in only 88 Earth days. Neptune, far beyond the warmth of the inner solar system, requires an astonishing 165 Earth years. Even within our own planetary family, time already moves at dramatically different speeds. Now imagine shrinking that orbit even further. Instead of circling at a comfortable distance like Earth, imagine placing an enormous planet so close to its star that it races around it in little more than 20 hours. Or 16? Or 12. Some complete an orbit in less than 10 hours. Astronomers call many of these extraordinary worlds ultra-short period planets. Their names may sound technical, but their existence forces us to rethink something surprisingly simple. What does a year actually mean? If a planet completes 20,000 years during a single human lifetime, can we still think of a year as a meaningful measure of time? Or is it merely a local habit, one that only makes sense from where we happen to live? Perhaps time itself feels less universal than we often imagine. Our calendars, after all, are not laws of nature. They are souvenirs of Earth's orbit. Every civilization has watched the changing sky and built stories around its own celestial rhythms. The ancient Egyptians followed the flooding of the Nile. The Maya carefully tracked the movements of Venus. Modern society measures fiscal years, school years, and anniversaries using Earth's steady path around the sun. But none of these ideas would survive unchanged on a planet where the year lasts only a few hours. Imagine waking up in the morning. By lunchtime, another year has already passed. By dinner, yet another. Before midnight, perhaps two more. A child only 1 Earth-year-old would already have experienced hundreds of birthdays. Imagine trying to explain age there. How old are you? Oh, approximately 12,000. The number would sound impressive, but it would tell you almost nothing. Life would need an entirely different way of measuring time. Perhaps the inhabitants, if such worlds could ever support life, would count days instead. Or perhaps they would measure the slow evolution of their star rather than the frantic motion of their planet. Because when a year becomes too short, it loses the meaning we instinctively attach to it. But this raises another fascinating question. How can a planet survive while orbiting so incredibly close to its star? Wouldn't the intense gravity simply pull it apart? Wouldn't the overwhelming heat destroy everything? In many cases, the answer is almost yes. These planets occupy one of the harshest environments in the galaxy. Their stars dominate the sky, appearing dozens of times larger than our sun appears from Earth. The daylight, if there's any distinction between day and night at all, can become unimaginably bright. The radiation is relentless. The temperatures often climb well beyond 1,000 degrees Celsius. Many of these planets are so close to their stars that powerful tidal forces gradually change the way they rotate. Just as our moon always keeps one face toward Earth, these worlds often become tidally locked. One hemisphere permanently faces the star, the other remains trapped in eternal darkness. Imagine living on such a world. There would be no sunrise, no sunset. One side would experience endless daylight, where the star never moved across the sky. The opposite side would never see daylight at all. Instead, it would remain frozen beneath an everlasting night, illuminated only by distant stars. Between these two extremes may lie a narrow twilight zone, where the temperatures are less hostile. Astronomers sometimes wonder whether, under the right conditions, such regions could become surprisingly stable despite the violence surrounding them. It is an extraordinary thought. A planet completing an entire year every few hours, yet never experiencing a sunrise. The universe delights in combining ideas that seem completely incompatible. Fast years, motionless skies, blazing daylight beside endless darkness. Every strange world reminds us that our everyday experience represents only one tiny possibility among countless others. In many ways, Earth occupies an unusually gentle corner of the cosmos. Our orbit is nearly circular. Our seasons change gradually. Our day lasts 24 hours. Our year lasts 365 days. Our temperatures remain within a relatively narrow range. It is easy to mistake this balance for the universal standard. But astronomy tells a different story. Normal is simply what happens here. Elsewhere, planets race around their stars so quickly that the concept of a calendar almost dissolves. Elsewhere, a single Earth week contains more planetary years than an entire human lifetime has birthdays. Elsewhere, time itself seems to dance to a rhythm unlike anything our ancestors could have imagined. And perhaps that is one of the quiet lessons hidden among the stars. The universe does not organize itself around human expectations. It does not care how we define months or years. It simply follows gravity. Where gravity is gentle, planets move slowly. Where gravity is overwhelming, planets race through space with astonishing speed. The clock changes, but the laws remain beautifully consistent. As our telescopes continue discovering new planetary systems, we are slowly assembling a much larger picture of reality. A picture where time stretches and compresses depending entirely on where you happen to stand. On Earth, a year feels long enough to watch children grow, forests change, and memories accumulate. On another world, a year might pass before you've taken your next breath. And somewhere in the vast darkness of the Milky Way, there may be countless planets that have already celebrated millions of New Year's days, while the light carrying news of their existence is only just arriving here on our small blue world. 3. The worlds with more than one sunrise. What would the sky look like if dawn arrived twice? Or even 7 times? Here on Earth, sunrise is one of the few experiences almost every human being shares. No matter where you live, morning usually unfolds in a familiar way. The eastern horizon slowly brightens. The stars quietly fade. Shadows stretch across the landscape. Then, almost effortlessly, the sun climbs above the horizon, announcing the beginning of another day. For thousands of years, poets, sailors, farmers, and astronomers have all watched this same daily performance. It feels so natural that we rarely stop to consider how unusual it might actually be. Because Earth has only one sun, one star, one predictable sunrise every day. But the universe is under no obligation to follow Earth's traditions. Among the countless planetary systems scattered across our galaxy, there are worlds where the sky tells a very different story. Imagine standing on the surface of an alien planet as the first dawn begins. A brilliant golden star slowly rises, bathing the landscape in warm light. For a few hours, everything appears almost familiar. Then, just as that first sunrise reaches its highest point, a second star emerges over another horizon. The shadows suddenly split into two. The ground glows with two different colors of light. The sky itself becomes brighter than anything ever experienced on Earth. And if that sounds extraordinary, there may be planets where the performance becomes even stranger. Astronomers have discovered many stars that do not live alone. In fact, most stars in our galaxy are thought to belong to binary or multiple star systems. Instead of one star orbiting peacefully through space, two stars dance around one another, sometimes three, occasionally even more. Entire families of stars bound together by gravity. If planets form within these remarkable systems, their skies may become almost impossible to imagine. Some worlds orbit close to one star, while another shines brilliantly in the distance. Others travel around both stars together, watching them circle each other in an endless celestial dance. From the surface, sunrise might depend not only on the planet's own rotation, but also on the ever-changing positions of several different suns. One morning could begin with a brilliant white star. Hours later, a smaller orange companion appears. On another day, both stars might rise together, creating a dazzling double dawn, unlike anything our eyes have evolved to expect. Thousands of years later, their positions shift again. Every sunrise becomes a new arrangement. No two mornings are exactly alike. We often think of the sky as permanent. Constellations remain almost unchanged throughout a human lifetime. The sun follows nearly the same path every year. Even the moon behaves with comforting regularity. Our ancestors built calendars because the heavens appeared wonderfully predictable. But on many exoplanets, the sky itself could become a constantly changing work of art. Imagine living your entire life beneath two moving suns. There would be moments when both stars illuminate the landscape simultaneously, producing multiple overlapping shadows that stretch in different directions. Trees, mountains, and even your own footsteps might cast 2, 3, or perhaps even 4 separate silhouettes across the ground. At sunset, one star disappears first. Twilight begins. Then suddenly, the second star remains. Darkness refuses to arrive. Hours later, the final sun finally slips below the horizon, allowing the first stars of the night to emerge. Night itself may become surprisingly brief or astonishingly long. Everything depends on the graceful choreography of gravity. And then there are systems even stranger. Over the past few decades, astronomers have discovered stars locked together in extraordinarily complex arrangements. 3 stars, 4 stars, in rare cases, even larger gravitational families. Not every one of these systems can support stable planets. Many would be far too chaotic. Their gravitational pull would constantly disrupt planetary orbits, eventually throwing worlds into deep space or pulling them toward one of their stars. But remarkably, some arrangements remain stable for billions of years. Gravity, despite its immense power, can create astonishing harmony. Computer simulations suggest that certain planets could experience skies illuminated by several suns at different times, each following its own path across the heavens. Imagine trying to invent a calendar there. Which sunrise marks the beginning of a day? Which sunset ends it? Would children learn the names of 6 different dawns instead of one? Would ancient civilizations build temples aligned toward multiple horizons? Would myths describe each sun as a different god crossing the sky? It is fascinating to realize how deeply our culture has been shaped by something as simple as having only one star. Even our language reflects it. We speak of the sunrise, the sunset, the morning, as though there could never be alternatives. Yet somewhere beyond our solar system, an entirely different civilization if one were ever to exist, might never understand those singular words. For them, dawn could be plural. Morning might arrive in layers. Light itself could become something far more complicated than we have ever known. Perhaps the most famous fictional example of this idea comes from worlds imagined in literature and cinema, where twin suns have become symbols of distant adventure. For many years, such skies belonged only to storytellers. Then astronomy quietly transformed fiction into reality. Today, we know that planets orbiting multiple stars are not merely possible. They exist. Some have already been confirmed. Others almost certainly await discovery. Every year, our telescopes reveal new planetary systems whose architecture seems stranger than anything we previously imagined. It is a gentle reminder that science fiction often becomes science fact, not because imagination predicts the future perfectly, but because reality frequently proves even more creative. Perhaps somewhere tonight, on a distant world orbiting two stars, an observer is watching an evening unlike any Earth has ever known. One sun has already disappeared. The second still hangs low above the horizon. The landscape glows in copper-colored light. Long shadows stretch toward mountains we've never seen. Above them, another star begins rising, while the first has not yet fully set. The sky briefly holds 3 suns at once, then 4. For those who call that planet home, nothing about it seems extraordinary. It is simply another ordinary morning, and perhaps that is one of the most beautiful ideas in astronomy. Every world believes its own sky is normal. Only by looking outward do we realize how wonderfully diverse the universe truly is. Earth's single sunrise is not the rule. It is merely one variation among countless possibilities scattered across the Milky Way. The farther we explore, the more we discover that the universe delights in rewriting our assumptions. One world rains molten iron. Another races through an entire year before we finish a night's sleep. And somewhere beyond the reach of our imagination, dawn may arrive, not once, but again and again, until the sky itself becomes an endless symphony of rising stars. If these quiet journeys through the universe are helping you unwind, consider subscribing, and let's keep exploring the impossible together. 4. The planets that wander alone forever. Not every planet belongs to a star. Some have been drifting through endless darkness for billions of years, completely alone. At first, that idea seems almost impossible to accept. After all, every planet we've ever known has circled a star. Mercury races around the Sun in just 88 days. Earth follows its familiar yearly path. Even distant Neptune, nearly 5 billion kilometers away, still remains firmly bound to the same brilliant star that warms our world. The Sun feels inseparable from the very idea of a planet. Without a star, could a planet even be called a planet? For centuries, astronomers assumed the answer was probably no. Planets, by definition, belonged to stars. That was simply how the universe worked. Stars were the parents, planets were their children, gravity held every family together. But once again, the universe quietly revealed that our assumptions were far too small. Some planets have no sun to orbit, no sunrise, no sunset, no dawn waiting beyond tomorrow. Only an endless journey through the silent darkness between the stars. These extraordinary objects are known as rogue planets. Sometimes astronomers call them free-floating planets. The names sound mysterious, but they describe something surprisingly simple. A world that has become untethered from every star. A planet that now travels alone. If you've ever watched leaves floating down a quiet river, you've seen something similar. Most remain close together. Some become caught along the riverbank. Others drift away, carried by invisible currents until they disappear from sight. The galaxy may behave in much the same way. Most planets remain loyal companions to their stars for billions of years, but every so often, gravity rearranges the story. Young planetary systems are surprisingly chaotic places. After a star is born, enormous disks of gas and dust surround it. Inside those disks, planets slowly begin taking shape. Small rocks collide, tiny worlds merge. Gravity pulls everything into an increasingly crowded neighborhood. For millions of years, countless planets, moons, asteroids, and comets compete for stable orbits. It is less like a carefully organized clock and more like a bustling city still under construction. Sometimes worlds pass dangerously close to one another. A giant planet may tug on a smaller neighbor. Another star passing nearby can disturb the entire system. Over countless encounters, gravity slowly steals momentum from one object while giving it to another. Eventually, one unlucky planet receives a final gravitational push, not toward its star, but away from it. Its orbit stretches farther and farther, until one day, it never comes back. Instead of circling its sun forever, it escapes into interstellar space. Imagine watching your home disappear forever. At first, the star would slowly shrink in the sky. The warmth would begin fading. The brilliant daylight that had illuminated the planet for billions of years would gradually weaken. Weeks become months. Months become years. Eventually, the once dominant sun would look no brighter than the countless other stars scattered across the heavens. Then, it would simply become another tiny point of light, one among billions. There would be no direction called morning, no horizon where dawn patiently waits. The very idea of east and west would slowly lose its meaning. Darkness would no longer arrive each evening. Darkness would simply become permanent. It is difficult to imagine such loneliness. On Earth, even our darkest night skies are filled with reminders of the sun's influence. The moon reflects its light. The planets shine because of it. Our seasons, our climate, even every breath we take, ultimately depend upon its energy. Remove the sun, and our entire understanding of existence changes. Yet rogue planets continue drifting through that unimaginable darkness. Some may have wandered for billions of years, longer than multicellular life has existed on Earth, longer than the dinosaurs ruled our planet, longer than our solar system has completed even a single orbit around the center of the Milky Way. They simply keep moving, silently, patiently, without destination, without sunrise, without anyone to witness their journey. For a long time, astronomers wondered whether such lonely worlds could even be detected. After all, planets usually reveal themselves because their stars betray their presence. Sometimes a planet briefly blocks a tiny fraction of starlight. Sometimes its gravity causes the star to wobble ever so slightly. Without a nearby star, how do you find a planet that emits almost no light of its own? The answer lies in one of Einstein's most beautiful predictions. Gravity bends light. If a rogue planet drifts precisely between Earth and a distant background star, its gravity acts like an invisible magnifying glass. For a brief moment, the distant star appears slightly brighter. Then, the effect disappears. The wandering planet moves on. The star returns to normal. Astronomers call this phenomenon gravitational microlensing. The event may last only hours or days, but hidden within that fleeting flash is evidence that an invisible world has silently crossed our line of sight. It is one of the few ways we can discover planets that refuse to orbit any sun at all. And remarkably, the more we search, the more rogue planets we seem to find. Some estimates suggest there could be billions of them scattered throughout our galaxy, perhaps even more rogue planets than stars themselves. Imagine that for a moment. The Milky Way may contain an enormous hidden population of worlds drifting unseen between the stars, entire planets moving through darkness, waiting to be discovered. Yet, Perhaps the greatest surprise is that these frozen wanderers may not all be completely lifeless. At first, that seems impossible. Without sunlight, temperatures should plummet toward absolute zero. Oceans should freeze solid. Atmospheres should collapse. Everything should become silent ice. But nature often finds unexpected ways to preserve warmth. Deep inside many planets lies enormous internal heat left over from their violent formation. Radioactive elements continue releasing energy for billions of years. Gravity itself slowly compresses the interior, generating additional warmth. If a rogue planet possesses a thick enough atmosphere, especially one rich in hydrogen, it might trap that internal heat surprisingly well. Far beneath an endless frozen surface, hidden oceans of liquid water could potentially survive, not warmed by sunlight, but by the planet itself. Here on Earth, life already flourishes around deep-sea hydrothermal vents where sunlight never reaches. Entire ecosystems survive using chemical energy rising from the planet's interior. If Earth can support life without sunlight in its deepest oceans, could similar environments exist beneath the frozen crust of a wandering rogue planet? No one knows. Perhaps somewhere between the stars, beneath kilometers of ancient ice, warm oceans quietly flow in complete darkness. Perhaps simple organisms have lived there for hundreds of millions of years, never once seeing a sunrise because their world has none. It is a breathtaking possibility. A lonely planet, drifting forever through the blackness of interstellar space, yet still carrying the quiet spark of life beneath its frozen shell. The universe has a remarkable habit of reminding us that loneliness does not always mean emptiness. Some of its most extraordinary stories unfold far from the warmth of any sun. And somewhere tonight, while we rest beneath the comforting light of our own familiar star, countless rogue planets continue their endless voyage across the galaxy. No destination, no home, only gravity and time, guiding them through an ocean of eternal night. 5. The hottest planets ever discovered. There are places so unbelievably hot that even metal becomes vapor, and the surface glows brighter than some stars. When most of us imagine heat, we think of familiar extremes: the blistering sands of the Sahara, the flowing lava of an erupting volcano, the intense flames inside a steel furnace. These temperatures feel almost unimaginable because they push the limits of everyday human experience. Yet by cosmic standards, Earth is astonishingly cool. Even our hottest deserts barely reach 50 degrees Celsius. Fresh lava emerges at around 1,000 degrees. The surface of the sun, by comparison, is nearly 6,000 degrees Celsius. The difference is so enormous that our planet almost seems like a quiet oasis floating through space. And then there are the hottest planets ever discovered. Worlds that orbit so close to their stars that they exist in an environment where the very concept of a solid surface begins to lose its meaning. These planets are not merely warm. They are not simply scorching. They exist in a realm where chemistry itself starts behaving differently. Rock melts, minerals evaporate, entire landscapes may become oceans of molten stone. The night sky, if there is one at all, glows with the heat radiating from the planet itself. Some of these worlds are so hot that they shine in infrared light almost as brightly as small stars. Imagine standing on such a planet. Of course, no human ever could. No spacecraft built by humanity could survive there for long. But for a moment, imagine that somehow you were protected from the impossible conditions. There would be no cool breeze, no clouds drifting peacefully overhead, no rivers winding through green valleys. The ground beneath your feet might resemble glowing glass fresh from a furnace. Mountains could slowly soften under temperatures that never truly fall. Rivers, if they exist, may not contain water at all. Instead, they could flow with liquid rock. Even the horizon would appear unfamiliar. Heat rising from the landscape would constantly distort the view. bending light into shimmering waves. The sky itself might glow faintly orange from the enormous energy surrounding you. It would feel less like standing on a planet and more like standing inside an enormous industrial furnace stretching all the way to the horizon. Yet these extraordinary worlds are not accidents. They are simply the natural consequence of one thing: distance, or more precisely, the lack of it. Earth enjoys a remarkably comfortable position around the sun. Astronomers often call it part of the habitable zone, a region where temperatures allow liquid water to remain stable over long periods. Move a little closer. The oceans slowly begin to evaporate. Closer still. Runaway greenhouse effects transform the climate into something resembling Venus, where surface temperatures become hot enough to melt lead. Move even closer than that, and an entirely different class of planets begins to emerge. Many of these worlds complete an orbit in just a few Earth hours. Their stars dominate the sky, appearing dozens of times larger than our sun appears from Earth. The amount of energy striking their surfaces every second is simply overwhelming. Imagine holding your hand near a campfire. Move twice as close. The warmth becomes uncomfortable. Move 10 times closer. You instinctively pull away. Now imagine moving thousands of times closer to something millions of times more powerful than that fire. That is the reality for many of these extraordinary planets. The star never grants them a chance to cool. Its radiation constantly floods the atmosphere with unimaginable energy. Over millions of years, the planet reaches an uneasy balance. Whatever heat escapes into space is immediately replaced by fresh energy pouring in from its nearby star. The result is an eternal state of blazing equilibrium. Some worlds become so hot that scientists have detected vaporized minerals high above their atmospheres: silicon, iron, magnesium, titanium. Materials we normally associate with mountains and metal tools become gases drifting through alien skies. Weather itself begins using the building blocks of rock instead of water. Clouds may form from minerals rather than moisture. Rain may fall not as water, but as molten droplets of metals or condensed stone. The entire water cycle that defines Earth's climate simply disappears. Nature does not stop creating weather. It merely changes the ingredients. One of the strangest consequences of such extreme heat involves light itself. Here on Earth, planets are dark. They reflect sunlight, but produce very little visible light of their own. The moon shines because sunlight bounces off its surface. Mars appears reddish because it reflects sunlight. Jupiter glows softly because sunlight illuminates its clouds. But some of the hottest exoplanets have become so incredibly hot that they emit their own light. Not because they are stars. They lack the enormous mass needed for nuclear fusion. Instead, they glow because they are simply hot enough. Heat radiates away in the form of light. The entire planet becomes a dim ember floating through space. Imagine seeing an entire world glowing like the heating element inside an electric oven. It is an astonishing thought. A planet that seems to produce its own sunrise. Some of these worlds may even appear brighter than certain cool, faint stars located much farther away. It reminds us that the boundary between planets and stars is not always as obvious as it first appears. Nature prefers gradual transitions rather than sharp categories. The universe rarely draws clean lines. Instead, it paints gentle gradients. Cold worlds become warm worlds. Warm worlds become scorching worlds. Scorching worlds begin glowing. Beyond them lie brown dwarfs, objects too massive to be ordinary planets, but too small to sustain the nuclear fusion of true stars. Then, finally, the stars themselves ignite. Everything exists along a magnificent continuum. As astronomers discover more exoplanets, they repeatedly encounter worlds occupying places along that continuum that no one expected. Each new discovery expands the range of environments we know can exist. It also expands our appreciation for the remarkable balance found here on Earth. Our oceans remain liquid. Our atmosphere stays relatively stable. The rocks beneath our feet remain solid. The sun warms us without consuming us. That delicate balance is far rarer than we once believed. Many worlds are too cold. Many are too hot. Some swing violently between extremes. Others spend billions of years locked beneath eternal daylight or endless darkness. Earth, by comparison, occupies an unusually gentle corner of the galaxy. Perhaps that is why life has had the opportunity to flourish here for so long. When we study the hottest planets ever discovered, we are not merely looking at distant curiosities. We are learning just how many different ways a planet can exist. Each one is another reminder that the universe is far more inventive than human imagination. Some worlds race around their stars in only a few hours. Others wander forever without any star at all. Some experience multiple sunrises every day. Others are wrapped in permanent darkness. And then there are these extraordinary infernos. Planets so hot that mountains may slowly melt, metals become clouds, and entire worlds glow like embers suspended in the endless night of space. The farther we journey from our own familiar home, the more we begin to realize that Earth is not the template for the universe. It is simply one beautiful possibility among countless others waiting to be discovered. 6. The giants larger than we thought possible. How large can a planet become before it stops being a planet? Nature seems to enjoy pushing that boundary. Here on Earth, it is easy to imagine planets as familiar places. Rocky landscapes, towering mountains, deep oceans. Perhaps if they are much larger than Earth, we picture a more massive version of our own world. Stronger gravity, thicker clouds, and broader horizons. But once again, the universe quietly reminds us that our intuition is built from only one tiny example. Because somewhere among the countless stars of the Milky Way are worlds so enormous that they blur the very definition of what a planet is. At first glance, asking how large a planet can become sounds like a simple question. Surely astronomers must know the answer. After all, a planet is just a very large object orbiting a star. Make it bigger, and you simply have a bigger planet. Except, that is not how nature works. Unlike people, mountains, or oceans, planets cannot continue growing forever. Eventually, something remarkable happens. Gravity begins changing the object itself. Imagine building a snowball. At first, each handful of snow simply makes it larger. Double its size, and you have a larger snowball, triple it, and larger still. But imagine continuing forever. Eventually, the enormous weight pressing inward would begin crushing the snow beneath its own gravity. The structure itself would change. The same principle applies throughout the universe. The more mass a planet gains, the stronger its own gravity becomes. For rocky worlds like Earth, greater gravity means denser interiors. Iron sinks deeper toward the core. Pressure climbs to unimaginable levels. Atoms are squeezed closer together than anything we encounter in daily life. But giant planets tell an even stranger story. Jupiter, the largest planet in our solar system, contains more than twice the mass of all the other planets combined. If Earth were the size of a grape, Jupiter would be roughly the size of a basketball. It is an astonishing giant. Yet astronomers have discovered planets even larger, much larger. Some possess several times Jupiter's mass. Others appear so enormous that, when they were first detected, scientists briefly wondered whether they had actually found small stars instead. That confusion reveals something fascinating. The universe does not separate planets and stars with a bright dividing line. Instead, there is a mysterious middle ground, a region where enormous planets, failed stars, and tiny stars begin resembling one another. Astronomers call some of these objects brown dwarfs. The nickname often given to them is failed stars. It sounds almost tragic, as though they tried to become stars and somehow didn't succeed. But perhaps that description is a little unfair. Brown dwarfs are not failures. They simply occupy a different chapter in nature's story. To understand why, we need to ask another question. What makes a star a star? The answer is surprisingly simple. Not light, not size, not even temperature. A true star shines because deep inside its core, enormous pressure ignites nuclear fusion. Hydrogen atoms collide with such incredible force that they merge together, releasing staggering amounts of energy. That energy travels outward as light and heat. It is the process that has powered our own sun for over 4.5 billion years. Planets never achieve those conditions. No matter how large Jupiter becomes, its core never grows hot enough to sustain ordinary hydrogen fusion. Gravity alone cannot quite finish the job. Yet, if enough mass is added, something curious begins to happen. The object starts behaving less like a planet and more like a star that never fully awakened. For a brief period, it may fuse a rare form of hydrogen known as deuterium. Then, after exhausting that limited fuel, it slowly cools again. Not quite a planet. Not quite a star. Something in between. It is one of astronomy's favorite reminders that nature dislikes sharp categories. The universe prefers smooth transitions. The largest planets gradually resemble the smallest brown dwarfs. The largest brown dwarfs gradually resemble the smallest stars. Where exactly should astronomers draw the line? There is no perfectly satisfying answer. Nature simply continues, while humans invent names. Perhaps the strangest part is what happens as giant planets become more massive. Common sense suggests they should also become dramatically larger. Twice the mass, twice the size. 10 times the mass, 10 times the size. But reality behaves very differently. After reaching approximately the size of Jupiter, adding more mass produces surprisingly little increase in diameter. In some cases, the planet actually becomes smaller. At first, this seems impossible. How can adding more material make something shrink? The answer lies, once again, in gravity. As mass increases, gravity presses inward with extraordinary force. Instead of allowing the planet to expand, the additional weight compresses its interior more tightly. The object grows heavier, but not necessarily wider. Imagine squeezing a pillow. The more pressure you apply, the denser it becomes. Something similar happens inside giant planets, although under pressures millions of times greater than anything on Earth. Deep beneath their clouds, hydrogen behaves in astonishing ways. It transforms into liquid, then into metallic hydrogen, a strange state where the simplest element in the universe begins conducting electricity like a metal. We have nothing remotely comparable on Earth's surface. Entire oceans of metallic hydrogen may swirl thousands of kilometers beneath the colorful clouds of giant planets. Powerful electrical currents flowing through these exotic layers generate magnetic fields of incredible strength. If you could somehow descend into those hidden depths, the pressure would become so immense that every human-made submarine would be crushed long before reaching the interior. Eventually, even atoms themselves begin behaving differently. It is a world governed by physics almost impossible to recreate in laboratories. And yet, these colossal planets are surprisingly common throughout our galaxy. Many orbit so close to their stars that astronomers call them hot Jupiters. Others circle far away in icy darkness. Some possess atmospheres inflated by intense stellar radiation, making them appear strangely oversized. Others are so dense that they challenge our understanding of planetary formation. Each new discovery forces scientists to refine theories that once seemed complete. The more planets we find, the more complicated the universe becomes. Perhaps that should no longer surprise us. Every chapter of our journey has revealed another assumption quietly falling away. We believed planets always orbited stars. Some do not. We believed every year lasted something like our own. Some last only a few hours. We believed sunrise belonged to a single sun. Some worlds experience several. We imagined weather meant clouds and water. Some planets rain molten metal instead. Now, we discover that even something as fundamental as the size of a planet refuses to follow simple rules. There is no universal blueprint, no perfect design, only gravity, time, and endless variation. Somewhere tonight, beyond the reach of every telescope visible to the naked eye, enormous worlds continue circling distant stars. Worlds larger than anything our ancestors could have imagined. Worlds whose immense gravity compresses matter into forms unlike anything found on Earth. Worlds balanced delicately on the invisible boundary between planets and stars. They remind us that the universe is wonderfully reluctant to fit inside the categories we create. Every time we think we have reached the edge of possibility, the cosmos quietly stretches that boundary a little farther. And perhaps somewhere beyond the giants we already know, another world waits to be discovered, one even larger, even stranger, and ready to redefine, once again, what it truly means to be called a planet. 7. The worlds orbiting dead stars. Long after a star has exhausted its fuel and collapsed, a few stubborn planets may still continue their silent journey through space. When we look up at the night sky, the stars appear timeless. They shine with such quiet confidence that it's easy to imagine they have always been there, and always will be. For thousands of years, our ancestors believed the stars were permanent lights fixed to an unchanging heaven. Even today, despite everything we've learned about astronomy, there is something comforting about their steady glow. Night after night, year after year, generation after generation, the same familiar constellations return. But stars are not eternal. Like every living thing in the universe, they are born. They grow, they change, and eventually, they die. The difference is simply one of scale. A human life is measured in decades. A giant tree may survive for thousands of years. A star measures its life in billions, so long that the entire history of human civilization has unfolded during little more than the final fraction of a second on the cosmic clock. Our own sun is approximately halfway through its lifetime. It has quietly fused hydrogen into helium for nearly 4.5 billion years. Every sunrise you've ever witnessed, every ocean wave, every breath taken by every creature that has ever lived, has been powered by the same ancient nuclear furnace. Yet even the sun cannot burn forever. One day, billions of years from now, its fuel will begin to run low. The balance that has kept it stable for so long will slowly disappear. Gravity will start winning its endless battle against the pressure produced by nuclear fusion. The sun will begin to change. Its outer layers will swell outward, far outward. It will become a red giant, expanding until Mercury disappears. Then, Venus. The fate of Earth remains uncertain, but our planet may also be consumed by the growing star, or, at the very least, transformed into an unrecognizable wasteland. The oceans will vanish. The atmosphere will escape into space. Every mountain, every continent, every trace of humanity will eventually disappear beneath unimaginable heat. For a brief cosmic moment, the sun will become larger than it has ever been. Then, just as quietly as it began, the expansion will end. Unable to sustain itself any longer, the star will shed its outer layers into space. Beautiful clouds of glowing gas will drift away, forming what astronomers call a planetary nebula, a name that, despite its beauty, has nothing to do with planets at all. At the center, only the star's exposed core remains. A white dwarf, about the size of Earth, yet containing roughly half the mass of the original sun. A single teaspoon of its material would weigh several tons. The brilliant star that once illuminated an entire planetary system has become something entirely different, smaller, denser, fainter, yet astonishingly hot. It no longer creates energy through nuclear fusion. Instead, it slowly radiates away the heat accumulated during its long lifetime. Over trillions of years, it will gradually cool, becoming dimmer and dimmer until it finally fades into darkness. At least, that is the story of the star. But what about the planets? For a long time, astronomers assumed that the death of a star marked the end of its planetary system. It seemed inevitable. How could fragile worlds survive such unimaginable violence? The expanding red giant would surely destroy everything nearby. The enormous loss of mass would destabilize every remaining orbit. Any survivors would be scattered into deep space. It sounded like the final chapter. But once again, the universe chose a more complicated ending. Over the past few decades, astronomers have discovered compelling evidence that some planets continue orbiting stars long after those stars have died. Some are survivors. Others may even be newcomers, born from the remnants of destruction itself. Imagine witnessing the end of your sun. For millions of years, the sky grows brighter. The familiar star expands until it dominates the heavens. Its light becomes redder. Its warmth becomes unbearable. Entire climates collapse. Then, after the outer layers drift away into space, silence returns. The once mighty star has shrunk into a tiny white point of dazzling light. The sky becomes dark once more. But gravity remains. Although the star has lost much of its mass, it still possesses enough gravity to hold distant planets in orbit. Their years become slightly longer as their orbits expand. Yet they continue circling the silent ember that once gave them life. Imagine standing on such a distant world. Your sun would no longer resemble the warm yellow star we know. Instead, it would appear as an intensely bright white jewel hanging in an unusually dark sky. Smaller than our sun appears from Earth. Far hotter in color, yet producing far less warmth. Its light would seem strangely beautiful, almost ghost-like, a reminder of what once existed. If life somehow survived or evolved long afterward, it would grow beneath the light of a dead star. That idea almost sounds like poetry. Life illuminated by an ancient stellar ghost. Even more remarkable is the possibility that entirely new planets might form after a star dies. When a red giant sheds its outer layers, enormous amounts of gas and dust spread outward into surrounding space. Under the right conditions, some astronomers believe this material could eventually gather together once again. New planets, born from the ashes of an old solar system. In a sense, the death of one planetary family could become the beginning of another. Nature has always excelled at recycling. The carbon in your body was forged inside ancient stars that died long before our sun was born. The calcium in your bones, the oxygen you breathe, the iron flowing through your blood, all were created in stars that reached the end of their lives billions of years ago. Perhaps planets, too, can participate in that endless cycle of renewal. Old stars giving rise to new worlds, destruction quietly becoming creation. Astronomy often reminds us that endings and beginnings are not opposites. They are simply different moments in the same story. And perhaps nowhere is that more beautifully illustrated than around dead stars. These silent stellar remnants no longer blaze with the youthful energy that once illuminated their planets. Yet they still shape the universe. They still hold worlds in their gentle gravitational embrace. They still whisper clues about what may one day happen to our own solar system. In many ways, observing these ancient systems is like looking into Earth's unimaginably distant future. One day, billions of years from now, our descendants, if any remain, may no longer recognize the sun. The familiar golden disk will have vanished forever. In its place, a tiny white ember will shine quietly against the darkness. Perhaps somewhere beyond it, distant planets will continue their patient revolutions. Perhaps frozen moons will still circle forgotten giants. Perhaps nothing living will remain. Or perhaps life will have found another way. We simply do not know. That uncertainty is one of the reasons astronomy remains so endlessly fascinating. Every answer reveals another mystery waiting just beyond it. Every dead star carries the memory of an entire planetary system that once flourished beneath its light. And every surviving planet reminds us that even after the brightest chapters come to an end, the story itself may continue for billions of years more. If tonight's discoveries are filling you with a little more wonder, subscribe and join me for the next chapter of our cosmic adventure. 8. The planets that shouldn't exist. Astronomers keep finding worlds that seem to break the rules of planetary science, yet the evidence says they're real. Science is often described as the search for answers, but in reality, it is just as much about discovering better questions. Every generation of astronomers has believed it possessed a reasonably complete picture of how planets form. Clouds of gas collapse to create a young star. Around that newborn star, a vast disk of dust and gas begins to spin. Tiny grains collide, pebbles become rocks, rocks become worlds. Over millions of years, gravity patiently assembles an entire planetary system. It is an elegant story, simple, logical, beautiful, and for a long time, it appeared to explain everything we observed in our own solar system. Rocky planets close to the sun, gas giants farther away, ice worlds beyond them. The farther from the sun, the colder the planets became. The pattern seemed almost perfect. Then astronomers pointed their telescopes toward other stars. Almost immediately, the universe began rewriting the textbook. The very first exoplanets we discovered were not distant, frozen giants like Jupiter. Instead, many of them were enormous gas planets orbiting astonishingly close to their stars. Some completed an entire orbit in only a few days, others in less than a single Earth day. According to the theories scientists trusted at the time, such planets should not exist. There simply wasn't enough cool material near a young star for giant planets to form. The temperatures would be too extreme. The gases needed to build worlds like Jupiter should have been blown away long before they could gather. Yet there they were, not one, not two, but many. The evidence became impossible to ignore. Nature was doing something we had failed to imagine. Today, astronomers call many of these worlds hot Jupiters, gigantic planets, sometimes even larger than Jupiter itself, orbiting so close to their stars that their years last only a matter of days. Finding the first one was shocking. Finding hundreds completely transformed planetary science. Instead of asking, can planets like this exist? Scientists suddenly had to ask, how did they get there? One possible answer is surprisingly dramatic. Perhaps these giant planets did not form close to their stars at all. Perhaps they were born much farther away, where temperatures were low enough for enormous quantities of gas to accumulate. Then, over millions of years, gravity slowly pulled them inward. Interactions with neighboring planets, collisions, the gravitational influence of the surrounding disk, even distant companion stars, all may have acted together, gradually changing their orbits. Like enormous ships carried by invisible currents, these giant worlds slowly migrated toward their stars. Eventually, they reached the blistering environments where we observe them today. The idea sounded radical when first proposed. Now it has become one of the leading explanations for many strange planetary systems. Once again, the universe reminded us that planets are not necessarily born where we eventually find them. Some are travelers. Their histories are written across billions of years of slow gravitational change. But the surprises did not end there. Astronomers soon discovered planets orbiting stars that barely seemed capable of supporting planets at all. Tiny red dwarf stars, ancient stars poor in heavy elements, even the remnants of stars that had already died. Each discovery chipped away at assumptions that once appeared secure. One particularly fascinating mystery involves planets orbiting extremely small stars. According to older theories, these stars should possess only tiny disks of material during their formation. There simply shouldn't be enough building blocks to create large planets. Yet observations repeatedly revealed exactly that. Massive worlds circling surprisingly lightweight stars. Nature once again refusing to cooperate with our expectations. Then came another puzzle. Some planets are astonishingly large, yet remarkably light. Imagine an object almost as wide as Jupiter, but with only a fraction of its density. These strange worlds appear so puffed up that astronomers sometimes compare them to giant cosmic marshmallows. If you could somehow place one of them inside an enormous bathtub, assuming such a thing could exist, it might actually float. Of course, no bathtub large enough exists anywhere in the universe. But the comparison captures something remarkable. Planets can become so inflated by the intense heat of nearby stars that their atmospheres swell to extraordinary sizes. They appear far larger than their mass would normally suggest. Again, they seemed impossible. Until observations proved otherwise. The more carefully astronomers looked, the stranger the galaxy became. Then came planets that seemed almost too old. Some orbit stars formed early in the history of the Milky Way, when the universe contained relatively few heavy elements. Traditional theories suggested rocky planets should have been extremely difficult to build under those conditions. Heavy elements such as iron, silicon, magnesium, and oxygen are forged inside stars and spread across the galaxy when those stars die. Early generations of stars possessed relatively little of this material. So, where did these planets come from? Apparently, nature found a way. Every surprising discovery has forced astronomers to refine, not abandon, but refine their understanding of planetary formation. That is one of science's greatest strengths. A theory is never considered sacred. It survives only as long as observations continue supporting it. The moment reality disagrees, the theory must evolve, not reality. Reality never negotiates. It simply exists, patiently waiting for us to notice. Perhaps that is why astronomy remains such a humbling science. Every telescope ever built has revealed that the universe is more imaginative than the human mind expected. When we believed planets always orbited quietly in nearly circular paths, we found wildly eccentric worlds following elongated orbits. When we expected giant planets to remain far from their stars, we found hot Jupiters blazing only a few million kilometers above stellar surfaces. When we believed certain planetary systems were impossible, nature quietly presented them anyway, again and again. It almost feels as though the cosmos enjoys challenging certainty. Not maliciously, simply creatively. Every impossible planet eventually becomes another reminder that our understanding remains incomplete. And perhaps that is exactly how progress happens. Not by confirming everything we already believe, but by discovering the exceptions. The universe does not hand us finished answers. It offers puzzles, one extraordinary world at a time. Some of those puzzles eventually become ordinary. The first exoplanet once seemed astonishing. Today, thousands are known. Hot Jupiters once appeared impossible. Now they represent an entire category of planets. Who knows what today's impossible worlds will become tomorrow? Perhaps future generations will smile at our current confusion, just as we smile at older ideas about the cosmos. Perhaps they will discover entirely new classes of planets, unlike anything we have yet imagined. Worlds made primarily of water, worlds orbiting black holes, worlds drifting between galaxies, or environments so unfamiliar that today's astronomy textbooks contain no words capable of describing them. That possibility is both exciting and strangely comforting. Because it means the universe has not finished surprising us. Not even close. Every strange planet discovered over the past 3 decades has quietly whispered the same message. The cosmos is larger than our expectations, more creative than our theories, and infinitely more diverse than the single planetary system we once mistook for the universal blueprint. Somewhere tonight, hidden among the hundreds of billions of stars in the Milky Way, another impossible world is almost certainly waiting. It has already existed for millions, or perhaps billions of years. It simply hasn't revealed itself to us yet. But someday, a tiny flicker of starlight, a subtle gravitational tug, or the faint shadow of a distant transit may quietly announce its presence, and once again, the universe will gently remind us that impossible is often just another word for something we haven't discovered yet. 9. The most beautiful rings in the universe. One distant planet may wear rings so enormous they could swallow the orbit of Venus, creating one of the greatest sights we've never seen. When most people think of planetary rings, they picture Saturn. For centuries, it has been one of the jewels of our solar system. Even through a modest backyard telescope, Saturn appears unlike any other planet. Its delicate rings seem almost impossibly thin, floating around the giant world like a masterpiece suspended in space. It hardly seems real. In fact, when the Italian astronomer Galileo Galilei first observed Saturn in 1610, his telescope was too primitive to reveal the rings clearly. Instead, he thought the planet had mysterious ears. Later observations solved the mystery. Saturn wasn't wearing ears at all. It was surrounded by an enormous system of icy rings, unlike anything anyone had ever imagined. For hundreds of years, Saturn appeared unique. No other planet seemed capable of matching its beauty. Then, as astronomy entered the age of exoplanets, an extraordinary possibility emerged. What if Saturn's rings were not exceptional? What if they were modest? The idea sounds almost unbelievable. How could anything surpass Saturn? Its main rings stretch nearly 300,000 kilometers across while remaining astonishingly thin, often no more than tens of meters thick. Billions upon billions of ice particles, ranging from tiny grains to mountain-sized chunks, orbit together in graceful harmony. From afar, they appear almost solid. Up close, they resemble an immense swarm of glittering ice, each fragment following its own quiet path around the planet. They are already one of the most beautiful structures known in astronomy. And yet, somewhere far beyond our solar system, astronomers believe an even more astonishing ring system may exist. Not twice as large, not 10 times larger, but hundreds of times larger than Saturn's. So vast that if it replaced Saturn's rings in our own solar system, it would dominate the night sky. The rings would stretch so far into space that they could easily engulf the entire orbit of Venus. Trying to imagine such a structure is almost impossible. Distance itself begins to lose meaning. On Earth, we measure journeys in kilometers. Within the solar system, astronomers often speak in millions of kilometers. But this extraordinary ring system extends for tens of millions of kilometers. It is less like a ring and more like an entirely separate world surrounding another world. The object believed to possess these astonishing rings is known as J1407b, one of the most fascinating planetary candidates ever proposed. Although astronomers are still studying its exact nature, the evidence suggests something truly extraordinary passed in front of its parent star. For several weeks, the star repeatedly dimmed in an incredibly complex pattern. Not once, not twice, but hundreds of separate dips in brightness appeared. At first, the observations made little sense. A single planet crossing a star produces one smooth decrease in light. This event was completely different. The star flickered over and over again, almost as though dozens of enormous objects were passing in front of it. Eventually, researchers proposed an astonishing explanation. Not dozens of planets, one planet, surrounded by an immense system of gigantic rings. Each ring blocked a different fraction of the starlight as it moved across our line of sight. The changing brightness acted almost like a fingerprint. By carefully analyzing those tiny variations, astronomers reconstructed what may be the largest ring system ever discovered. If their interpretation is correct, this single planetary companion possesses more than 30 distinct rings. Some appear separated by enormous gaps. Others seem remarkably dense. Together, they form a structure unlike anything known within our own solar system. Those empty gaps may be especially interesting. Astronomers suspect they are not empty by accident. Instead, they could mark the locations where newly forming moons are slowly carving pathways through the rings. The process may resemble what happened around Saturn billions of years ago, except on a vastly larger scale. In other words, we may not simply be looking at rings, we may be witnessing the birth of an entire family of moons. That thought is breathtaking. Imagine watching our own solar system 4 billion years ago. Saturn's moons had not yet fully formed. Its rings stretched much farther into space. Countless icy fragments collided gently, gradually assembling larger and larger worlds. Perhaps J1407b offers us a glimpse into that ancient chapter of planetary history, not by traveling backward through time, but by observing another system still passing through a similar stage. Astronomy often works this way. The universe is so enormous that somewhere, almost every chapter of cosmic history is happening right now. While one star is being born, another is dying. While one planetary system has reached peaceful maturity, another is only beginning. The galaxy serves as an enormous museum where every exhibit represents a different moment in time. By studying distant worlds, we are also studying the past, and perhaps even the future, of our own. Now imagine standing on one of the moons orbiting this incredible giant. If such a moon exists within the ring system, the view would almost certainly surpass anything human beings have ever witnessed. The sky would not contain a thin arc, like Saturn's rings appear from some of its moons. Instead, enormous luminous bands could stretch from one horizon to the other. Some rings would appear brilliant white, reflecting the light of the nearby star. Others might glow softly in shadow. Dark gaps would separate immense rivers of icy debris. As the moon slowly orbited its planet, the appearance of the rings would subtly change each day. There might never be two identical nights. Sometimes the rings would dominate the sky like a celestial highway. Other times they might cast enormous shadows across the landscape below. Imagine watching sunrise beneath such a sky. The first rays of starlight would strike the rings long before reaching the ground. The heavens would gradually brighten in layers, each ring reflecting light at a slightly different angle, the entire sky becoming an enormous luminous sculpture suspended overhead. Even shadows would behave differently. The rings could partially block the incoming light, producing delicate bands of darkness sweeping slowly across the surface as the day progressed. No artist could fully capture such a scene. Reality itself would become the masterpiece. Perhaps that is one of the quiet joys of astronomy. The farther we explore, the more beauty we discover. Not only beauty in the traditional sense, but beauty born from physics itself. Gravity creates elegance. Motion creates harmony. Time transforms chaos into breathtaking order. Every ring particle obeys the same simple laws. Yet, together they produce structures so magnificent that they seem almost deliberately designed. It reminds us that nature needs no architect. Complexity emerges naturally when simple rules are given enough time. And the universe has had plenty of time, billions upon billions of years, long enough for stars to live and die, long enough for planets to migrate across entire solar systems, long enough for giant rings to grow, evolve, and perhaps slowly disappear as their material gathers into newborn moons. Nothing lasts forever. Even Saturn's beautiful rings are temporary. Astronomers believe they may slowly fade over the next 100 million years as gravity gradually pulls their icy particles onto the planet or assembles them into larger bodies. Perhaps the same fate awaits every ring system in the universe. Beauty, like so many things in nature, is often fleeting. Maybe that is what makes these distant rings feel even more extraordinary. Somewhere tonight, circling a star we can barely see, an enormous planet may still wear the largest rings ever discovered. Silent, graceful, almost unimaginably vast. A masterpiece suspended in the darkness of space, waiting patiently for the light of a distant star and for curious minds on a small blue planet to notice that even Saturn's greatest treasure may not be the universe's most spectacular one. 10. The tiny stars with giant companions. Sometimes the smallest stars are accompanied by worlds that appear almost impossibly large beside them. When we imagine a planetary system, we usually picture something similar to our own. A large brilliant star dominates the center. Around it, much smaller planets quietly circle in graceful orbits. The star is the giant. The planets are the tiny companions. It seems almost obvious. After all, our sun contains more than 99% of all the mass in the solar system. Jupiter, enormous as it is, would still fit inside the sun more than 1,000 times over. Everything about our cosmic neighborhood teaches the same lesson. Stars are overwhelmingly larger than planets. Planets are merely the supporting cast. But once astronomers began exploring the rest of the galaxy, they discovered that nature is wonderfully reluctant to follow familiar patterns. Some stars are astonishingly small, not merely smaller than the sun, but barely large enough to qualify as stars at all. And orbiting some of these tiny suns are planets so enormous that, at first glance, the pairing almost seems backwards. It is as though a tiny candle were somehow accompanied by an enormous lantern. The proportions feel completely wrong, yet they are real. To appreciate how remarkable these systems are, we first need to understand something about stars themselves. The sun is often described as an average star. That statement is true in some ways, but in another sense, it is surprisingly large. Most stars in the Milky Way are actually much smaller. These are known as red dwarfs. They burn their fuel slowly and efficiently. Many are only a fraction of the sun's diameter. Some possess less than 1/10 of its mass. If our sun were replaced by one of the smallest red dwarfs, daylight on Earth would look more like an endless sunset. The star itself would glow with a deep reddish color, producing far less light than the familiar golden disk we know today. Yet, despite their modest appearance, red dwarfs are remarkably successful. Astronomers estimate they make up roughly 3/4 of all the stars in our galaxy. That means if you could travel across the Milky Way, most of the stellar neighbors you encountered would not resemble our sun at all. They would be smaller, cooler, dimmer, quietly burning for trillions of years. Some may outlive the sun by hundreds of billions, or even trillions of years. Long after stars like ours have faded into white dwarfs, many red dwarfs will still be shining. They are, in many ways, the marathon runners of the universe. And around these quiet little stars, astronomers have found some surprisingly oversized worlds. Imagine looking up from the surface of one such planet. Your sun would appear much smaller than the one we know on Earth. Its light would be softer, tinged with shades of orange and crimson. The daytime sky, if the atmosphere scattered light in a similar way to Earth's, might never become the brilliant blue we take for granted. Instead, the landscape could be bathed in a perpetual amber glow. Yet despite the star's modest size, the planet itself might rival Jupiter, or even exceed it. The contrast is striking. The star seems almost delicate, the planet immense. From a distance, the pair resembles a parent walking beside a child much larger than itself. At first, astronomers struggled to explain how such systems could form. According to traditional models, larger planets require enormous disks of gas and dust surrounding young stars. The more material available, the larger the planets that can eventually emerge. Tiny stars should possess tiny disks. Tiny disks should build tiny planets. The logic seemed straightforward. Reality, however, had other ideas. Again and again, telescopes revealed giant companions orbiting surprisingly lightweight stars. Each discovery forced scientists to revisit assumptions that had once appeared perfectly reasonable. Perhaps these disks were more efficient than expected. Perhaps giant planets formed unusually quickly. Perhaps neighboring stars influenced their birth. Or perhaps we still misunderstand important parts of the process entirely. The universe has not yet revealed its full answer. And perhaps that uncertainty is part of astronomy's enduring charm. Every solved mystery quietly gives birth to another. Some of the most fascinating examples blur the distinction between planets and brown dwarfs. A giant companion orbiting an extremely small star may contain dozens of times the mass of Jupiter. At what point should we stop calling it a planet? Should classification depend on size? On mass? On how it formed? Astronomers continue debating these questions because nature rarely arranges itself into neat categories. Instead, it prefers smooth transitions. A small star, a giant planet, a brown dwarf. The boundaries between them often become surprisingly difficult to define. If an alien astronomer living elsewhere in the galaxy studied our own solar system, perhaps they would classify objects differently than we do. Nature has no labels. Only humans insist on naming things. Gravity, meanwhile, remains completely indifferent. It simply allows whatever combinations are physically possible. One of the reasons these systems attract so much scientific attention is that they challenge our intuition about balance. We often imagine the largest object controlling everything around it. And in one sense, that remains true. Even the smallest star still contains enough mass to dominate the orbit of its planetary companion. Yet appearances can be deceiving. Place a Jupiter-sized world beside a tiny red dwarf, and suddenly, the difference between star and planet no longer seems so overwhelming. The star still shines, the planet still reflects. But visually, they almost resemble equals. It reminds us how deeply perspective shapes our understanding of the universe. If humanity had evolved around a tiny red dwarf instead of the sun, perhaps our expectations would be completely different. Perhaps we would consider giant planets around small stars perfectly ordinary, and systems like our own solar system might seem unusually bright and oversized. Normal, after all, depends entirely on where you begin. As astronomers continue discovering more exoplanets, one lesson has become increasingly clear. The solar system is not a template. It is one example, beautiful, remarkably stable, wonderfully suited to the emergence of life, but only one story among hundreds of billions. Elsewhere, stars come in every imaginable size. Some burn blue and brilliantly hot, living only a few million years. Others glow faintly red for trillions. Some live alone. Others dance in pairs or larger families. Around them circle planets unlike anything our ancestors could have imagined. Frozen wanderers with no sun, worlds where molten iron falls from the sky, planets completing years in only a few hours, giants balanced on the threshold between planets and stars. And now, tiny suns accompanied by enormous worlds that seem almost too large for their humble hosts. Each discovery gently reshapes our understanding of what is possible, not by replacing the old picture entirely, but by making it larger, more complete, more beautiful. Perhaps that is the greatest gift astronomy offers us. Every time we think we understand the universe, it quietly invites us to widen the frame just a little more, to accept that nature is under no obligation to match our expectations, and to remember that somewhere, beneath the soft crimson light of a tiny long-lived star, a giant world continues its silent orbit, an unlikely partnership that has endured for millions, perhaps billions of years, reminding us that the cosmos is filled not with exceptions to its rules, but with rules we are only beginning to discover. 11. The impossible skies of alien worlds. On some planets, the sky may never look the same twice, with strange stars, shifting shadows, and horizons unlike anything on Earth. For most of us, the sky is so familiar that we hardly notice it anymore. Morning begins with soft blue light. Clouds drift slowly overhead. At sunset, the horizon glows orange and crimson before fading into deep blue. Night arrives, revealing the moon, a handful of bright planets, and thousands of distant stars. It is a rhythm that has accompanied humanity for hundreds of thousands of years. Every civilization has looked upward. The Egyptians aligned pyramids with the heavens. Polynesian navigators crossed entire oceans by reading the stars. Ancient philosophers searched the sky for answers about the universe and our place within it. Even today, despite satellites and skyscrapers, we instinctively glance upward whenever the sky begins to change. It feels permanent, reliable, almost universal, but perhaps nothing could be further from the truth. The sky above Earth is not the standard. It is simply one version among countless possibilities. Somewhere beyond our solar system are planets where the heavens would seem almost magical to human eyes. Places where sunrise paints the clouds in unfamiliar colors, where several suns drift across the same sky, where shadows refuse to behave as they should, where the horizon itself may glow throughout the night. Imagine stepping onto one of those distant worlds for the very first time. At first, everything might appear strangely familiar. There is a horizon, an atmosphere, mountains in the distance. Then you look up. Instead of a blue sky, you see something entirely unexpected. Perhaps the atmosphere scatters light differently. On Earth, tiny molecules scatter blue wavelengths more efficiently than red ones, giving our daytime sky its familiar color. But change the atmosphere. Add different gases, increase the pressure. Fill it with microscopic particles unlike anything found on Earth. Suddenly, the entire sky transforms. It could appear lavender, copper, golden, even deep crimson at midday. On Saturn's moon, Titan, for example, the thick atmosphere gives the landscape an orange glow unlike anything we experience here. Now imagine atmospheres even stranger than Titan's. Planets rich in methane, hydrogen, sulfur compounds, or chemical mixtures that have never existed naturally on Earth. Each one would paint the heavens differently. The sky itself becomes a fingerprint of the planet's atmosphere. Then there is the star, or perhaps the stars. Earlier in our journey, we visited worlds with more than one sunrise. Now imagine living beneath those skies every single day. Two suns slowly crossing different paths overhead, one brilliant white, the other glowing deep orange. As they move across the heavens, each produces its own shadow. Stand beneath a tree. Instead of one shadow stretching behind you, there are two, perhaps three. As the stars continue moving, the shadows slowly separate, merge, disappear, then return. The landscape itself becomes a constantly changing work of art. Even something as simple as walking across a field would feel unfamiliar. Your own shadow might point in several directions at once. Artists born on such a world would develop entirely different ideas about light and perspective. Perhaps their paintings would seem impossible to us, yet perfectly ordinary to them. Then imagine evening arriving. On Earth, sunset follows a simple pattern. The sun disappears, twilight fades, stars emerge. But on another world, one sun sets while another remains. Darkness hesitates. The sky glows in layers. One horizon burns with golden light, while another slowly fills with stars. Hours later, The final sun finally slips below the horizon. Night begins, but even night may not resemble our own. Suppose the planet possesses enormous rings, far larger than Saturn's. Those rings could remain visible long after sunset, stretching from one horizon to another like luminous rivers suspended across the heavens. Moonlight, or perhaps starlight, would reflect from billions of icy particles, creating an arch of glowing silver that never truly disappears. There might never be a completely dark night. Children growing up beneath such skies would consider those enormous rings perfectly ordinary. Only visitors from Earth would stand speechless. Then there are planets orbiting red dwarf stars. Their suns are cooler, dimmer, redder. To human eyes, daylight there might resemble the final moments before sunset on Earth. The world could spend its entire existence bathed in warm amber light. Blue skies might never exist. Green forests, if they evolved, could even appear black or dark purple as plants adapted to harvest different wavelengths of light. The familiar colors of Earth are not universal. They are local. Even rainbows could look different. On Earth, sunlight passing through raindrops separates into the familiar spectrum of colors. But alter the atmosphere, change the star, modify the chemistry, and rainbows themselves might display entirely different shades. Imagine explaining to someone that on your world, rainbows glow primarily in deep crimson and infrared colors invisible to human eyes. It would sound like fantasy. Yet physics allows countless variations. One of the most astonishing possibilities involves tidally locked planets. These worlds always keep the same face toward their star. One side experiences eternal daylight. The other remains trapped beneath endless night. Between them lies a narrow region, often called the Terminator. Imagine standing there. The sun never rises, it never sets. It simply hangs forever near the horizon. Every hour of every day of every year, time passes. Yet the sky barely changes. To the east lies permanent darkness filled with stars. To the west burns an eternal sunrise. Walk a few hundred kilometers toward the daylight side, and the star slowly climbs higher. Travel in the opposite direction, and darkness gradually consumes the sky. Entire civilizations, if they existed, might organize themselves around these invisible boundaries, some choosing endless daylight, others preferring eternal night, some settling forever beneath an unchanging twilight. What would mythology look like on such a world? Would people believe the sun had frozen in place? Would darkness become a mysterious frontier? Would explorers spend generations crossing landscapes where the sky slowly changes simply because they are walking across the planet? Here on Earth, we think of sunrise as a daily event. Elsewhere, it might become a destination. Even gravity can influence the appearance of the heavens. On giant planets with enormous moons, the sky might be dominated by a neighboring world hanging overhead. Imagine looking up to see a moon so large it occupies a quarter of the sky. Mountains, craters, clouds, perhaps even oceans, visible with the naked eye. Its phases changing week after week, its reflected light illuminating the night more brightly than any full moon on Earth ever could. Tides would rise dramatically. Stories and legends would revolve around that magnificent celestial companion. Children would grow up believing every planet has an enormous world suspended overhead. Only later would they discover that their home is the exception. Astronomy teaches us something wonderfully humbling. The skies we know are not ordinary. They are simply familiar. Everything we call normal, our blue daylight, golden sunrise, white moon, single sun, gentle seasons, and familiar constellations, is the product of one particular planet orbiting one particular star in one quiet corner of the Milky Way. Elsewhere, the heavens tell entirely different stories. Some skies glow red. Others are illuminated by multiple suns. Some never experience true darkness. Others never witness a sunrise. Some display rings stretching across the heavens like celestial bridges. Others reveal giant neighboring worlds hanging permanently overhead. Every alien sky is a different masterpiece, painted with the same fundamental laws of physics. Different ingredients, different perspective, different beauty. Perhaps somewhere tonight, beneath a sky unlike anything humanity has ever witnessed, another civilization is looking upward with the same sense of wonder that has inspired us for thousands of years. Perhaps they too believe their heavens are ordinary. Perhaps they tell stories about the strange lights above them. Perhaps they wonder whether somewhere across the immense darkness between the stars, another world exists with skies too extraordinary to imagine. If they do, they would be right. Because the farther we explore the galaxy, the more we realize that the universe has created not one sky, but billions, each one quietly waiting for someone to look up. 12. The wonders we haven't found yet. After discovering thousands of extraordinary worlds, astronomers believe we've barely scratched the surface of what the Milky Way is hiding. As our journey through these remarkable worlds slowly comes to an end, perhaps the most extraordinary realization is not what we've already discovered. It's what we almost certainly haven't. For centuries, humanity believed there were only a handful of planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, the distant ice giants that would later join the family. For thousands of years, that seemed like the complete inventory of planetary worlds. The night sky looked familiar, comforting, understandable. Then, in the final years of the 20th century, something quietly changed forever. Astronomers found the first confirmed planet orbiting a sun-like star beyond our solar system. One discovery, one tiny world, a single distant point hidden in an ocean of stars. At the time, few people could have imagined how quickly everything would change. Soon, another planet appeared, then another. Dozens became hundreds. Hundreds became thousands. Today, we know that planets are not rare exceptions. They are one of the universe's favorite creations. Every direction we look, stars seem to possess companions. Some systems contain one world, others contain several. Some may host entire families larger than our own solar system. The Milky Way alone is thought to contain hundreds of billions of stars. If even most of those stars possess planets, the number of worlds in our galaxy alone becomes almost impossible to imagine. Hundreds of billions, perhaps even trillions, each one with its own history, its own weather, its own sky, its own story unfolding quietly beneath distant stars. And yet, we have directly confirmed only a tiny fraction of them. Imagine standing on the shore of Earth's largest ocean. You scoop up a single glass of water. Inside that glass, you discover thousands of fascinating living creatures. Would you conclude you understand the entire ocean? Of course not. You would probably suspect the greatest mysteries remain beneath the waves. Astronomy finds itself in much the same position. The thousands of exoplanets we've already discovered are not the complete collection. They are merely the first handful, the first sip from an unimaginably vast cosmic ocean. Every strange world we've explored during this journey has taught us exactly the same lesson. Reality is more inventive than expectation. We found planets where molten iron falls like rain, planets completing years in only a few hours, worlds wandering forever without a parent star, giant planets orbiting tiny suns, ring systems so enormous they challenge our imagination, skies illuminated by multiple stars, ancient planets circling stellar remnants long after their suns have died. Every one of those discoveries would have sounded like science fiction only a few generations ago. Today, they are part of astronomy. Which naturally leads to a fascinating question. If these are the worlds we've already found, what kinds of planets remain hidden? Perhaps there are planets whose surfaces are covered almost entirely by oceans hundreds of kilometers deep. Scientists have already identified several candidates that may contain extraordinary amounts of water. Imagine standing on a world where no continent has ever existed, an endless horizon of waves stretching beneath unfamiliar stars. Or perhaps somewhere there exists a rocky planet surrounded by an atmosphere unlike anything in our solar system. Clouds formed from chemicals we've never encountered naturally on Earth. Storms driven by entirely different physics. Rain that falls not as water. Nor molten iron, but something even stranger. Perhaps there are planets orbiting black holes, illuminated not by ordinary sunlight, but by the intense radiation produced as surrounding material spirals inward. At first, such an idea sounds impossible, but over the past few decades, astronomy has repeatedly taught us to be cautious whenever we use that word. Impossible has become a surprisingly temporary description. Again and again, observations quietly transform impossibilities into realities. There may even be planets drifting through the vast emptiness between galaxies, entire worlds ejected from their home galaxies during ancient gravitational encounters, now traveling through intergalactic space where almost no stars illuminate the sky. Imagine living there. The Milky Way itself might appear only as a distant spiral of light suspended across eternal darkness. Night would become almost absolute. The universe would seem unimaginably lonely. Yet, even there, gravity would continue its quiet work. Time would continue flowing. The universe never truly stops creating. Perhaps the most exciting possibility involves something even simpler: entire classes of planets that we haven't imagined yet. History offers an important lesson. People rarely predict discoveries accurately. No one imagined hot Jupiters before they were found. No one expected planets wandering alone through interstellar space. Few believed giant ring systems could exceed Saturn's by such astonishing proportions. Reality consistently outperformed imagination. Why should the future be any different? Somewhere beyond the reach of today's telescopes may exist environments so unfamiliar that our current scientific vocabulary cannot adequately describe them. Not because physics breaks its own laws, but because those laws produce combinations we have not yet witnessed. Every improvement in technology expands our view a little farther. The first telescopes revealed moons orbiting Jupiter. Later instruments uncovered distant galaxies. Space telescopes discovered thousands of exoplanets. Now astronomers are beginning to study the atmospheres of those distant worlds. Instead of merely asking whether a planet exists, we can sometimes detect traces of water vapor, carbon dioxide, methane, perhaps one day, even possible signs of biology. Imagine what future generations may accomplish. Telescopes many times larger than today's. Space observatories positioned far from Earth's interference. Artificial intelligence helping analyze enormous oceans of astronomical data. Perhaps one day scientists will create direct images of distant Earth-sized planets. Not tiny points of light, but actual worlds, cloud systems, continents, oceans, seasonal changes. Imagine seeing another pale blue world for the very first time, not as an artist's illustration, but exactly as it truly appears. That single image could become one of the defining moments in human history, because beneath those clouds, there might be nothing, or there might be forests, oceans, weather, perhaps even life. For now, we simply do not know. And perhaps that uncertainty is not something to fear. Perhaps it is something to treasure. Mystery has always been one of humanity's greatest motivations. It inspired sailors to cross unknown oceans, explorers to climb distant mountains, scientists to build larger telescopes, children to ask impossible questions. Without mystery, discovery would lose much of its meaning. The Milky Way still contains hundreds of billions of stars. Beyond it lie hundreds of billions of galaxies. Each galaxy contains its own countless suns. Each sun may possess its own family of worlds. the numbers become so immense that the human mind naturally struggles to picture them. Yet every one of those distant planets is a real place, a real world, following its own orbit at this very moment. Whether anyone will ever stand there, whether life has emerged, whether oceans rise beneath alien moons, whether impossible skies stretch above unfamiliar mountains, those questions remain unanswered for now. But history suggests something comforting. Every generation inherits a universe slightly larger than the one known by the generation before it. Our ancestors knew only the wandering planets visible to the naked eye. We know thousands of worlds beyond our solar system. Future generations may know millions, perhaps one day, billions. The map of the universe is still mostly blank, and that may be the most beautiful discovery of all. No matter how much we learn, there will always be another horizon waiting beyond it. Another star, another planet, another impossible sky, another mystery quietly orbiting in the darkness, waiting for curious minds to find it. Perhaps somewhere, at this very moment, the next extraordinary world we've yet to imagine is completing another orbit around its distant star. It has existed for millions, or even billions, of years. It does not know we are searching for it, and it does not need to. The universe has always been patient. It has been quietly creating wonders long before humanity first looked up at the stars, and it will continue doing so long after we are gone. All we can do is keep looking, keep wondering, and allow ourselves to be humbled by the beautiful realization that, after everything we've discovered, we are still standing at the very beginning of the greatest exploration in history. If this peaceful journey across the galaxy helped end your day with a little more curiosity, consider subscribing, and I'll be here when you're ready to explore the next mystery of the universe.